Hello, dear students. I am Dr. Kapil Chaturvedi, Associate Professor in Department of Computer Science and Engineering, SIIT Sage Group Bhopal. In this lecture, we will discuss Big Data Analytics and Hadoop under our subject Data Analytics. So, in previous lectures, we discuss about what is actually big data, and we know very well that what is the meaning of big data. We discuss about data mining and the related step to gather knowledge from huge amount of data. Now we will discuss what is big data analytics. So as you can see the diagram in which you can see we are representing a big data. Big data, it means a huge amount of data which is collected from heterogeneous sources. So we have to apply data analytics. It means we have to apply different algorithms, or we have to provide the data for our data analytics tool so that we can gather appropriate knowledge and make appropriate decision on the basis of that knowledge. So as official definition, big data analytics is the use of advanced analytics techniques against very large, diverse data sets that include structured, semi-structured, and unstructured data from different sources and in different sizes from terabytes to zettabytes. So what we discuss in simple words, we have a huge amount of data and we have to apply different techniques over the data to fetch the knowledge to make decisions. So what we will do to actually apply data analytics over the big data? So the answer is we have some data analytics tools like Hadoop, Wiki, Spark, MongoDB, R programming environment, Elasticsearch. We have so many kind of data analytics tools, different kind of a big library of data analytics tools we have to mine the big data. So big data analytics is a process used to extract meaningful insights such as hidden patterns, unknown correlations, market trends, and customer performances. So basically, big data, we analyze the big data to find out such kind of information from that big data. Sorry, such kind of knowledge from the data. As we discuss, we have a lot. So we have a big library of data analytics tools. So there we have some open source big data analytics tools like Hadoop, MongoDB, Cassandra, Spark, and Storm. So Hadoop helps in storing and analyzing data that this is the fundamental tool. And MongoDB used on datasets that changes frequently. So here each and every tool have their own beneficial features, and on the basis of their features we will use the appropriate tool to analyze a particular kind of data on the basis of particular kind of knowledge what we have to fetch, which we have to fetch. Cassandra, a distributed database used to handle chunks of data, and Spark is basically work like MapReduce, but this is it has a faster speed in compared to MapReduce. It works 100 times faster than MapReduce. Used for real-time processing, analyzing large amount of data because it is the Spark work very fast. Storm, and open source real-time computational system. So there we have different open source tool. In further lectures, we will discuss in detail each of big data analytics tool. Now, if we discuss about Hadoop in detail, so we have two part of Hadoop. First part is HDFS and second part is MapReduce. Basically, HDFS is Hadoop distributed file system, which is used to manage the big data, and MapReduce is a part which explains how the process data efficiently, fastly. So tax take care of storing and managing the data in Hadoop cluster, as we discussed, and process the data which is present within HDFS. So this is the processing functionality, and this one is um, data storing functionality. Now, recently we discussed about Hadoop 1.0. Now we have Hadoop 2.0 also available, which has additional feature of Yarn, which provides the resource management functioning smartly to better utilization, to much more utilization of Hadoop framework. Now we have to discuss Hadoop in detail. So as we discuss, as I told you, that we have two part of Hadoop. First one is the Hadoop distributed file system known as HDFS, and second one is MapReduce. So here we will discuss the Hadoop's HDFS uh, structure, architecture. So to better understand that, you'll have to keep in mind as Hadoop work in the concept of distributed data. It means that distribute the data in multiple nodes, and that one more thing is that not only extract the data and divide in multiple nodes, also that keep the replica of that data in different storages that may be in same country or different countries, and the actual place of storing the data is data centers. So that keep the replica of the data. So if we have to understand that, then we have to understand the functioning of NAM node, data node, metadata, and one more thing here which is not available, and which is yarn, YARN, YAR. So what that structure says, HDFS divide or stripe or create the segment of the data in different data nodes. So basically divide the data and distribute the data in multiple nodes, and that distributed data parts are known as the data nodes. There are the data nodes. Here we are representing with the rack one. Once we create the data node, we create the replica of this data node on another position, which is known as the rack 2. Now, the job of NAM node is to manage the functioning of data node, and like how data node create, what will be the size of the data node, and how to manage the functioning of data node, how to create replica. So all related working related to the data nodes will be monitored by the NAM node, and data node continuously send the heartbeat to the NAM node to tell that working is going on properly. Metadata is basically is a metadata repository which keep which keep information about the different data nodes, and what is what is the location of the data, where the replica is available, how we extract the data, and many more so on information. Or we can say that metadata is data about data. So metadata keep the information about that kind of data. So then we perform the client read write operation from the data. Here the client perform writing operation. Client, it means the end user and server. which reading or writing the data from the server. So this is HDFS. The basic functioning of that is that divide the data in multiple data nodes. Another diagram of HDFS is the similar thing is here: nav node, data nodes, replica, rack 1, client 2, replication processing. So this is the fundamental architecture of HDFS. How HDFS manage the data smartly. So the fundamental concept is to divide is that in that divide the data in multiple um, parts, or distribute the data in multiple nodes. That nodes are known as data nodes. Now the next part of Hadoop is MapReduce. So how MapReduce work? It majorly work in two steps: mapping and reducing. So we have the big data, and we have to find out the output. So what we have to do, if we are adopting the concept of MapReduce, then we have to first map the data, then we reduce the data, and we find out the output. To better understand that thing, we must have to discuss that example in which our target is to find out what that string says, or if you have to find out the word count operation, if you have to perform the word count operation over the data, over that paragraph. So if we apply map reduce, it means we have to apply mapping and reducing. So we use following steps like input splits, mapping, suppling, reducing, and final output. So what we have to do, our input is welcome to Hadoop class. Welcome to Hadoop class. Hadoop is good, Hadoop is bad. So the first step of map reduce will be input split. It means we separate the lines welcome to Hadoop, class Hadoop is, good Hadoop is, and bad. So we divide the string in multiple parts. Now we have to now we will apply the mapping. Mapping, it means we will try to find out how much time a particular word come in that particular string. It means we basically we are trying to find out the frequency of the particular words. So in the mapping phase, we check that welcome comes one time in this string, two comes one time, Hadoop is also come one time, class in one time, Hadoop in one time is one time, good one time, Hadoop one time is one time, and wed one time. Now, once we apply the mapping, it means we are mapping the words with their frequencies. Now, the suppling is a procedure in which we will put the same kind of word in a common block like bed. We found the bed only in this block, so we are putting we are drawing that giving the direction of bed to that block, class word, good one, and Hadoop one, Hadoop one, Hadoop one. It means Hadoop. We can see that Hadoop arrives here, Hadoop arrives here, and also Hadoop arrives here. So the arrow says that. So we are gathering Hadoop from these three blocks. Arrow is showing that from where our Hadoop where a particular word is coming. Is one, it means is one in the third block, and is one second block. To one and welcome one. Once we shuffle the word, it means once we keep the word on a same block of the same kind of word, to perform the reducer operation, in which we uh, will count what is the actual frequency of the word. So where we can see that word comes one time, class comes one time, good one comes one time, Hadoop three times, is two times, to one time, and welcome one time. Now, in the final step, we perform the final output by merging that. So we can see that the summary is where it comes one time, class time comes one time, good comes one time, Hadoop comes three times, is comes two times, and two comes one time, and welcome comes one time. So here we can see that the frequency of Hadoop is 3, and rest of the words frequency is less. So we can say that the document is about Hadoop. So this is the functioning of MapReduce, which explains us how we map the data, how we reduce the data. In between, we perform the input operation and something operation also. So this is the actual functioning of MapReduce. So in the next lecture, we'll discuss the further open source tools, and we'll discuss these in detail, like what is the functioning of yarn, and we'll also discuss how Hadoop 2.0 work. Thank you.